Triangle congruence, proving and applying SAS and SSS congruency criteria. Alrighty then, let's go. So here are the objectives. Prove triangles congruent by SAS and SSS congruence criteria. Understand that corresponding parts of congruent triangles are congruent and use CPCTC. Apply congruency criteria to increasingly intricate problems involving overlapping triangles and multiple triangles. Proving triangles congruent, SSS criteria, congruent triangle proofs. If all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using fewer parts, shortcuts. Otherwise, there's 6 things. First shortcut is side, side, side congruence theorem. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. Yes, we cut them in half. Let's see, segment AB is congruent to segment DE. Segment BC is congruent to segment EF. Segment AC is congruent to segment DF. They were marked. That's what it looks like. By side, 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 the triangles are congruent. We have to match them up. Triangle ABC is congruent to triangle DEF. Let's do a proof. We are given segment PQ is congruent to segment ST. So I marked it on the diagram. You should mark it on your diagram. Segment QR is congruent to segment TR. Okay, mark it on the diagram. I marked it on the diagram. That's given. And then we're given R is the midpoint of segment SP. So that's the midpoint. That is given. They're saying segment PR is congruent to segment RS. Well, that's by definition of midpoint. A midpoint splits a segment into 2 congruent segments. So look at our diagram. We have enough to prove the triangle is congruent by SSS congruence theorem. Number 2, let's see what we have here. Segment JL is congruent to segment NM. Marked it, that's given. K is the midpoint of 2 different segments, segment JN and segment LM. And that is given to us. So segment JK is congruent to segment NK by definition of midpoint. Also, segment LK is congruent to segment MK by definition of midpoint. Look at the diagram. It definitely looks like side, side, side congruence theorem to me. There we have it. From the diagram, you should know that vertical angles are congruent. We're not using that at this time, but it would not have to be given to us. A couple things we know without them telling us. Vertical angles and shared sides. SAS, another one of our shortcuts. This is our second shortcut. If 2 sides and the included angle of one triangle is congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. Included means the angle is between the sides, as in the diagram there. So a pair of sides. Segment AB congruent to segment DE. And then the angles. Angle B congruent to angle E, and then another set of sides so that the angle is between the sides. So segment BC congruent to segment EF. Side angle side. Triangle ABC is congruent to triangle DEF by side angle side. Another proof. Here we go. Segment JM is congruent to segment LN. Got it marked on the picture. They also give us angle JMN. As I read it, you should be finding it. Is congruent to angle LNM. That is given. There it is. Hopefully that's where you found them. So segment MN is congruent to segment NM. Now you know the order doesn't matter when you say segments are congruent, and that is a shared side. So reflexive property, that's the second thing we can tell without them telling us. So mark that. Now we do have angles in between two pair of congruent sides. So triangle JMN is congruent to triangle LNM by side-angle-side congruence theorem. Number 2. Segment AB is congruent to segment CB. Mark it on your diagram. Segment BD, and that was given. Segment BD bisects angle ABC. Okay, that is given. There's our bisector. That's the angle is bisecting. So it splits it into two congruent angles. So by definition of bisector, or angle bisector, didn't have enough room to put the angle in there. Okay, angle ABD is congruent to angle CBD. Segment BD is congruent to segment BD. We should see in the picture. It's a shared side. That's reflexive property. And we have an angle snuggled in between two pairs of congruent sides. So that is SAS congruence theorem.